First, I appreciate the chance to be here, and I'm expecting a very engaged audience, which makes it certainly more entertaining and interesting from my end. A little bit of background: Milton Geiger. I'm with Poudre Valley Rural Electric Association. You're all probably very familiar with us because you are going to likely sending us a payment each month for electricity. But I've been with the co-op for 3.5 years. Have background university setting as well, University of Wyoming. I'm actually an economist by training, but I was joking with somebody earlier. I rarely put letters behind my name, but here it's Certified Energy Manager, Renewable Energy Professional. What that's really saying is somebody else says that I should know what I'm talking about, but you guys can make up your own mind at the end. And a couple of things on how I like to present. The first thing is I don't like to present. I'd rather have a conversation, rather interact back and forth, so feel free to bring questions as we're going. And I've prepared sort of a shell, a framework, and there's a lot of directions where we can have these conversations. I really want to focus on what's interesting for you. And I also tried to stick to the prescribed topic here. I want to address the issues that you want to have addressed, not what I want to come here and tell you from the REA. So we're going to spend most of our time private power generation from wind and solar, and we'll sort of set a framework, and then we'll get into the specific topics, and then really how it works interacting with the utility on that. And from there, we can go into whatever other topics you'd like. I believe you're going to have access to the slides. There's a few links in there. All right. And I'll wing it from here. No. And I should also mention, I do always try to bring along free copies of the presentation if folks have problems or would prefer, rather, to have something in front of them. I do have free copies right here if you don't want to follow along on the screen, but once again, you'll have access to this after. So if anybody needs these are up here. Send them around. But with that, we'll jump right into it. So the very first question you want to ask, and this could be why renewables, but we'll just talk primarily about wind and solar, is why. Why are you looking at it? We want to make sure that we acknowledge each of you as individuals and have individual preferences, but really step back and look at, okay, why are we looking at this, and are we getting at what our needs or wants are from looking at private wind and solar? And by the way, when we talk about private wind and solar, I primarily deal with the larger installs for Poudre Valley REA, our larger solar, some of our small hydro, things like that. But certainly here we're going to focus on rooftops, think residential scale, ground mount. Really at we'll call it distributed generation, sort of a utility term, but distributed generation, actually a distributed energy resource, meaning you're generating it where you're consuming it. So we're going to focus on that scale, so sort of keep that in mind. But why wind or solar? And there's numerous reasons that come up from folks that call into the REA or previous life and university and elsewhere. But one of the first that comes up is save money, or you want to look at reducing price volatility. Hey, I want to lock in prices. We hear that a lot. We'll talk about how wind and solar stack up in that realm. We certainly have a branch of folks and now we can add batteries to this as well, that it falls under that technical fascination. And I don't want to downplay that. Are there folks in here, and you don't have to raise your hand, but would know how to fix a carburetor and actively have fixed a carburetor in the last 4 years? There's really no need to do that anymore, but you've got a technical fascination and you go ahead and do it. That's not a judgment play on what the return on investment is. It's like, hey, this is really interesting to me. This is how I want to invest my time and money. We certainly saw that as an early driver way back when, especially wind and solar, I think the early 80s, late 70s. That drove renewables when they weren't even close to the realm of cost competitive, but to some folks it's really fascinating. So I don't want to downplay that certainly comes into this conversation. Another piece of it is going to be that independence and resiliency, especially up here. I speculate that resiliency is going to resonate. And we can approach it from two angles. Some it's independence. Okay, you want to stick it to the cooperative. I'm done with the utility. We can certainly talk about that. And actually, renewables, wind and solar, make it possible to say, all right, I sort of like having your own garden. I want to grow it, I want to produce it, I want to use it. And if we look at that, that can change the parameters of what's an economically prudent investment for you. And a garden's a nice analogy for that. I speculate, well, I won't, but maybe you guys have a bit more challenges gardening up here than we would down in like Windsor. But I came from Laramie, and we used to joke that was a land of green tomatoes. But people still went ahead and did it. And if they actually put a pencil to how much it cost them to raise these bloody tomatoes, they would have never raised them. But hey, sense of independence, sense of satisfaction. So we don't want to downplay that. Resiliency, we'll talk about wind and solar. and how it can provide backup when the power goes down. Hopefully, and we always like feedback, but we've done quite a bit of sectionalizing, other improvements where the reliability, especially in this area, should be getting better. But there are certain aspects where short-term outages, but also in occasion where we have, events like wildfire that would take down the transmission line that serves you. Because you all are actually in utility speak on a radial service, meaning we got one way to get it in here. And it's at, you see there's a transmission line, the bigger, that's actually a 69 kilovolt, 69,000 volt transmission line that brings it up here, and that's sort of a sub-transmission level, but that's it. That's the only way Poudre Valley can get it in here. Down a little bit further, we can loop it in other ways, but so resiliency can come into play. And the other thing, certainly environmental concerns. We'll talk a lot about carbon, sustainability, however you want to phrase it, that can come into play with the conversation of what and why, really why you want wind and solar. But the takeaway here is, are you getting at your goal the best possible way? And I'll use a quick example here as I walk in. So save money or reduce price volatility. Great, I want to produce it, I'm going to make an investment, and then it's just going to reap savings. Well, if you really want to get at that, say at this building, I'd look up, and these are called T12 fluorescent lights. They're actually very much an older style. These likely have something called a magnetic ballast. I won't nerd out here too much, but each one of these tubes uses 75 watts. A new LED retrofit on this, a similar amount of light, you'd use about 26 watts. So same amount of light, actually they last longer. So if you wanted to save money before you put solar on the roof, I'd say, look up, right? And let's talk about efficiency, conservation, things like that. And you could pick for other things there. Say it was for environmental concern. I want to reduce my consumption, so I reduce my carbon footprint. Well, before wind and solar, maybe we want to talk about that. So that's one of the things that's most important. Why do you want to do this? Make sure you're getting at it the best way. You can always stack to it. And I actually like a framework here. This comes from some educational materials from the University of Wyoming. And used to joke, this is sort of modeled back when the food pyramid made sense, right? But when we want to think about alternative energy, wind and solar, the first thing is assessment. Most folks don't understand how they use energy very well. We'll spend just a little bit of time on that. Where you use it, how you use it, when you use it. And that opens up, okay, what are my opportunities? The first level would be conservation, simple behavior changes, right? This is Jimmy Carter telling you to put on a sweater type thing. Are there ways you can get at it there? Very low cost and pretty simple. And as we go up the pyramid, if you will, cost and complexity is increasing as well. So the next one would be efficiency. And when we talk about that, it's sort of the productivity. If you've got 1 kilowatt hour, how much useful work can you get out of it? Could you put in LEDs and get the same amount of light out of this with less inputs? If you're using electric baseboard heat, could you put in a cold weather air source heat pump that's twice to 2.5 times as efficient as electric resistance? Would that get you to some of the things that you're after there? Then at the top of the pyramid, not saying it's the best, it's just sort of increase the cost and complexity. Okay, how do I generate my own? And that's where we get into the conversation, wind and solar. And not to belabor any of that, but certainly starting with that, all right, understand how I use it, and then are there other things I can do first? You can reach out to us. We can talk all day about rebates and efficiency and things like that. But there's some exciting technologies out there that can really help you have control over how you use electricity first. So many of you are probably aware of that, but it's good to set the table. Understand that, okay, we're going to get to that wind and solar conversation, but before we have our dessert, if you will, that is wind and solar, maybe we take care of that main course of the vegetables. It would be, understanding how you use it, your behavior, and then efficiency. And the other thing is understand your usage. And sorry, that's just a bit blurry, but this comes from CSU Extension. And the takeaway is, in essence, eat the whole pie, if you will. And when we're talking about wind and solar, we're primarily talking about electricity consumption. And just help me understand the audience, how many folks use propane to heat, not electric resistance, or to have choice? So mostly propane, that was my understanding here. So this is typically going to apply here. But if you talk about wind and solar, we're really getting after this red right here is appliance, electronics, and lighting. It's really about a third, and this is a typical Colorado home. The other portions, about 19% goes to water heating, and 54% goes to heating. And you guys would be on the upper end of that. So when we're talking about your energy consumption, where I want to be independent, revert back to the same things, I want to save money. Let's not forget about the other half of the pie, or really the other 2/3 of the pie, that is how you heat your structure. We can talk about what you can do for efficiency, some of the substitutes, substituting electricity for propane, or other ways to make it more efficient. But when we focus on energy, know that the wind and solar that we're talking about, unless you're using electricity to heat your structure, we're only getting at that third of the pie right there. So I think that's very important, because a lot of times people overestimate that, oh, I got this electric bill, but really when you look at your overall energy consumption, a lot of it is in heating the structure and actually heating the water as well. Fair enough, nothing too earth-shattering here, but once again, sort of laying the table out here. The other thing is we get into the electricity. So now let's jump right into electricity. And I'm certainly going to explain stuff. Really, it's not the details of this graph, it's what's going on here. So there is a PVREA app, and I'll have the website in here. And by the way, app, you can also just get at and log into your account. Maybe some of you already have it. It's how you can pay your bill online. But you can log in and you can see your consumption. And Poudre Valley made an investment, like 7-8 years ago on getting something called Advanced Metering Infrastructure, AMI. And what that does is it gives us, a meter reader doesn't have to come out to your house anymore. That's a big help for us, and we're scattered all out over 3,500, nearly 4,000 miles of distribution line. But it also provides information on your consumption, and we share that right back with the members. The exact same stuff that we see at your co-op, you can get on and look at. So this would be logged into that app, and I pulled a representative home from up here. You see it's a winter peaking. Even if you're using propane, typically you'll use more if you're up here year-round, lighting, things like that. And you can see month-by-month consumption. And you can see there's an axis over there that it tells you, okay, here's your kilowatt hours, here's what the temperatures we're doing, because that's a primary driver, and understand how you use electricity. Fun thing is, if you really want to be an energy nerd, and maybe if you came out on a pleasant evening to learn about wind and solar, you might fall into that category. You could actually click on a specific day, and it's not a bad thing, by the way. I mean, I fully embrace it. My wife may not be impressed, but she married me, so what does that say? But anyway, so we have it. Here we look at, I just clicked on December 4th. How is energy being used? And this is actually broken down in 15-minute increments. And that's what the meter is reporting. By the way, it doesn't report real time, so it's not like we can look and say like, aha, Gordon's making a cup of coffee right now. We're gonna mess with him and send the voltage while. It's a delay. You would actually see if you log in here. It's about a day, sometimes 2 days behind, depending on how the mesh, how we actually get it is one meter talks with it and sort of like relays it along, if you will. But you have access to this, so you can understand how you're using electricity. So if you wanted to chase efficiency first, you'd be like, man, what was going on in this one day? It was so high. And you can look into that. I had people over and I had 4 crock pots plugged in or something like that, right? You can break that down. It really helps you understand how you're using energy and sets that base level of assessment. And the other thing is when we get into wind and solar, as far as sizing, this is very important. Because you want to look at your total consumption, but you also want to look at when you're using it. We'll talk about how that works in an incentive structure, but it's not just that aggregate number. It's, okay, how am I using it month to month? What's the resource going to be like in that month? Can I carry over credits in that following month? With net metering, we'll talk through that. But very, very useful. Encourage you to go on there. It's free, and we certainly, actually right now, there's even a contest. If you sign up, there's a drawing every month or so for some energy bucks on your bill. So really useful tool, and that's one of the perks about having the advanced metering infrastructure. So, and that's how you get to the app. Just on our website, it's a good place to look at it. Like I said, I have the link at the tail end of the presentation. Okay, the other thing I want to own right here. Some of you may be like suspicious here. Wait a second here, wind and solar, and I got a guy from the electric company. I don't care if you're a co-op and you own us, right? It's sort of the unique thing. I mean, you have equity in us, but they make money selling me electricity, and I want to generate it myself. That's, is this guy going to give me a straight story? First, I promise you I will. That's just sort of like my personal integrity, but I want to make sure we frame it and say what's going on from with wind and solar, really all renewables from the co-op perspective. So first, and I brought along a few of the flyers if you want, but on a broader scale, in June of this year, the board that you elect pledged to have 80% of our energy come from non-fossil resources, so primarily renewable energy, by 2030. That's a big deal. We're just a shade over 30% right now. Locally, we generate about 3.5%, so this is like a fundamental change in how we supply electricity. So wind and solar, from that perspective, we're going out and getting it. Like I said, my primary role is on the utility scale, but certainly at the individual scale, this can be a piece of getting us to that 80% by 2030, because it's a pretty audacious goal, honestly. When you look across the sector, it's on the higher end, and our board really went after it to try and be proactive, and the pricing helps. We'll talk about that. Now, things have changed where it does potentially make sense. So I've got some copies up here. You can find everything you want on this on our website, and it's going to guide what we're doing for the next 10 years or so, and likely beyond. So that's all right. Wind and solar, we like that. Well, we also have other opportunities relative to private solar. We have community solar, and you may be familiar with that. Once again, you're a co-op. We're a co-op. You own us. And the idea is we build a project, and you subscribe to the output of a certain number of panels. Our current, and that's our My Local Solar program, our current project's located adjacent to the Larimer County landfill, and you subscribe to the output, it gets credit on your bill just like it was on your roof. And the idea is not everybody can put it on their roof or wants it on the ground, and when you build it big, we can build it less expensively. For instance, those are single axis trackers. They follow the sun from east to west, so you're going to get 20% more production. You're not going to do that on a smaller scale. It's just not practical. So we have that option. So does that put us at odds with private solar? Not necessarily. We just recognize that not all our members wanted that, and we bring an alternative. But at the same time, and this is from the annual report, another nice thing about involvement, I did bring some of that along. Thank you, sir. We make money selling electricity. Now, we're a co-op, so we're a not-for-profit, but we're also a business. We have to have a margin to have a mission. We're not a government entity. We can't just give it away and hope somebody else subsidizes it. I mean, we have to, more has to come in than goes out. Otherwise, we've got a long-term problem there. And when we have wind and solar, it gets net metered, and it can be an impact to our existing model, which is based upon volumetric sales of energy. We used to have a meter with a spinning disc that was really good at measuring how much went through it. So that's sort of what we built for it. It almost like it was the odometer on your car. We didn't care how fast you went. We just cared about that total once a month. We knew we could bill on that, so there we go. So it's certainly a challenge to us, and we recognize that's coming from what our members want, but also technology is changing. So we don't have the blinders on, and occasionally we'll grumble about some of the challenges this brings. Our system was designed to have electricity go one way, and all of a sudden we're having to go two ways, but they aren't insurmountable. But I want to acknowledge that we're sort of split on this. But with that being said, we can certainly walk through the process. Go ahead.
So how much of your electricity do you generate?
Do we generate ourselves?
Yeah.
So, well, sort of ourselves, 100% of it, but we'll take it in two pieces. So Poudre Valley is part of Tri-State Generation and Transmission Association, which is actually a cooperative of co-ops, so a co-op of co-ops. And they're the ones that own the big transmission lines and the generation assets. The idea is came together. These are, especially when you're building a big coal plant or something in the past, those are billion-dollar plays, right? It's not something one individual co-op can do. And if you actually, when you get your bill, we assign something called capital credits, and some of them say tri-state, and that's what it is. That's what they pass down, and then we prorate it to your consumption. But as far as actually what we can generate locally, we have a carve-out in our contract that lets us generate up to 5% locally. Right now we've got about 18 megawatts of solar and hydro, which amounts to about 3.8% of what we consume that's generated locally. Some of the projects we contract with a third party. There's one on 14, just about the landfill out there. We've got one next to Larimer County landfill. We've got some on Kersey, in between Windsor and Greeley. We partnered with Northern Water to install a small hydro at Carter Lake. Things like that. So if you want how much does the Poudre Valley itself go and do, that'd be the fair number.
4%.
Yep. Anything else? Sort of setting the table here. All right, the first thing about wind and solar, when we talk about private wind and solar, it's all going to operate under something called net metering and interconnection. First, I'll just break it out. An interconnection is the physical interconnection of a generating facility with the electric grid. And that is really guided by safety and some of the system parameters, but pretty straightforward on interconnection. You apply to us, we tell you, okay, you're going to need this, you're going to need a disconnect that if we had to, we could lock it out if our lineman for some reason couldn't ground the lines there. And most inverters, we'll talk about what an inverter is, have smart controls where if they sense a loss of power, they're not going to be pushing something back onto the grid. So interconnection is a relatively straightforward process. The technical aspects of it are well understood, we've got it well defined, and as long as it's not some incredibly unique system that isn't using fairly standard off-the-shelf parts, straightforward process. Net metering, on the other hand, is a billing structure. And what that is, so we're going to talk here in the context of solar because that's the vast majority of the about 600 net metered systems we have on Poudre Valley system. We have about 43,000 meters, 600 net meters at the moment. So if we want to talk through the process, you've got solar panels, it generates in direct current, it goes into an inverter, goes into that alternating current that we know and love and that the utility deals in. And then this is where the net meter comes into play. Say you're producing more than you consume at the moment. Well, we have a bidirectional meter there, so it flows out onto the system. Now, once again, we make sure that's safely interconnected. There aren't some system constraints, but we haven't quite got to that point yet, so you get more and more renewables, you could. But it flows out onto the system, and it goes off. And electricity, batteries are starting to change this, but really they're consumed the moment they're produced. That's how we have grid stability. If they weren't, we'd see frequency changes and voltage changes, so it's produced, it's consumed somewhere, right? One on, one off. But so they're putting onto the grid, and great, we can think about it in a daily context with solar. Put it out during the day, come back at night, you flip on the lights, and it's not like Poudre Valley took the electrons that you were producing, put them in a jar for you, put your name on it, and handed it back to you. No, we do something called net metering, where it says, okay, you put one on during the day, we're going to give you a credit for putting one on, even when you're taking one off at night. And that actually goes from day to day, but also month to month. May is typically a very good month for solar in Colorado. Lots of sun, relatively cool. Not a huge amount of load yet usually. So a lot of times people produce more than they consume in May. Great, we can carry those over from month to month. And Poudre Valley actually elected to true up with you at the end of March, meaning if at the end of March you produce more than you've consumed for the year, we'll actually buy them from you. But we'll buy them from you at your avoided cost, or our avoided cost, which is about 4.5 cents. That's about the wholesale value of that electricity. So it's an accounting exercise. You get to carry it over from month to month, and that March true-up, by the way, is for you folks up in the mountains that are primarily heating dominated. You get a chance to chew through that bank that you built up in the summer in the winter season. But once again, just acknowledging where we come from in the electric utility, the electric co-op perspective, that is a little bit of a challenge for us in the fact that we give the full retail rate for one that goes out. And if you want to think about it, it goes out and uses the system, all these assets out there, all the people that keep the lines up, and you get the full retail credit back. So the best analogy I can give is like going into a grocery store and you got I guess I got some peaches out in the truck. We have a peach there. In the store, it's worth a certain amount. It's a different price out in the field, if you will, at the peach orchard. And that's really how it works for Poudre Valley. When it comes to the ultimate delivered, okay, that's got all the costs that go in with the system, everything from system stability, the poles, wires, the substations, contracts for transmission to keep that system balanced. So it is an incentive. In essence, you get the full retail rate for it, and we're, at that point, there's an implicit subsidy in it. Because we also, when Poudre Valley pays for electricity, not all electrons are created the same. It's sort of like rush hour. There's a certain half an hour each month that sets about 40% of our wholesale power bill. So we want to make sure that at that peak, we're reducing the peak. And solar's not always on at that time. So it doesn't always have the full value. It's not a complaint, it's just an acknowledgement. It is an incentive, but it works and it's a great component when it comes for you looking at wind and solar. Because you get to put them on there and then you get to take them off when you need it. You get credit on the bill. You don't have to do anything. You just see, all right, I've got this bank of electrons sitting in there showing each month, or I pulled from my bank each month. So that's net metering 101. It's kind of a difficult topic to walk through without a tangible example, probably a bill in front of you. But any questions on that? Because it really underpins all aspects of project. Very important though, and most residential systems, anything under 25 kW, up to 120% of your consumption is eligible for net metering. So that would be a very large system for a residential setting.
Thinking of the usage, there's peaks and valleys and stuff. How does the electrical company, how do you balance that? Say you have extra electrons, do they just kind of evaporators?
No, if you have extra electrons, you're going to get problems. So we, in a very tight band, have a voltage band that we have to deliver to you in, and also there's a grid-wide, the Western Interconnect, really from Nebraska to California, up into Canada, down to, includes Baja, Mexico, tries to stay on 60 hertz. So if you were forcing too much electricity in there, you'd throw that off. You'd actually drive it up, and if there wasn't enough generation, you'd see it creep down. So it is actually a real-time adjustment. So how's that done? Batteries may be a solution, but it's traditionally you've got a big rotating machine, think a steam turbine powered by coal or natural gas, and it's got a lot of inertia. And it feels like, all right, somebody's consuming more electricity somewhere. It calls for a little more fuel because it feels like it's slowing down. And alternately, there's fast response turbines that can turn on in an instant. Some are always spinning, and some can fire up in like less than 5 minutes. Say a power plant goes down, and all of a sudden we need lots of generation. Well, they're sort of trading among utilities. Say, okay, I've got this one. Let's get it on really quickly, and that's how it's all balanced right now. And it's really fascinating. I've been doing that for 75 years, really. So, but that's how it works traditionally. But once again, distributed energy resources are sort of changing that. So sure. How about here and then there? Go ahead.
I was just going to say, so batteries are the only way you can store electricity?
Right now, there's some pumped hydro, and actually Tri-State uses some of that, and it's a very complex process. They pump water uphill at night and let it come back down during the day. But otherwise, yeah, the best analogy is right now the electricity market is like the ag sector, like perhaps the beef cattle sector before refrigeration, except to an umpteenth degree, where you actually have to consume it the moment you produce it. And if you think about it, batteries are almost like refrigeration. It lets you take a product and store it for a later use. So, but yes, otherwise, really no way to store it. Different generation sources respond quicker. Sometimes hydro, sometimes gas is a fast response, and then it's typically underpinned by a coal plant that's sort of running flat out there. Stayed too long on one slide there. But sorry, go ahead.
So you would pay us 4.5 cents.
Go ahead.
And on average, what is the price that consumers pay?
Sure. So we pay 4.5% only on the stuff that you produce extra throughout the year. So you get a chance to like chew down that amount throughout the months. So our wholesale price, and actually it's specified in the, I should make sure I get my numbers right. So 79% of our expenses for 2018 were the cost to purchase power. So there's an energy component, which is a little north of 4 cents for wholesale, but there's also a big capacity component. And that capacity is set by that magic half hour each month, that sort of highest. That sets like, okay, that's what size of the system. And we're, let's see here, it varies with some of our industrial loads, but a little north of 7.5 cents for the purchase power cost. So the rest of that, if you want to think about it, is, well, paying for things like me, the distribution system, and some of the other expenses that go with that. So, but, great question.
And what are those big, almost like transformers on these power poles? I've seen different guys.
Sure, and I defer to some of my alignment and ops friends, but I highly speculate those are regulators. And what regulators do, we talked about the power is designed to go one way, and if you want to think about it, it comes down at the substation. Everybody familiar with what a substation is? I should have put a picture in here. You got big transmission lines and little lines, right? And a substation in between. That lowers the voltage. And when we put it there, it's at a certain voltage. But as you get further away from that, there's resistance on the line, there's loads, electric loads, voltage drops. Well, you can't drop outside that parameter. You'll get very grumpy with us, and our system won't work very well. So you hit regulator banks where it then brings the voltage back up. So I bet you that's what you'll see them. If it's on a 3-phase line, there'd be like a bank of 3 of them sitting there. We typically put them up in the air. Why? Because we find that people generally don't mess with things that are 12, 15 feet up in the air, and also keeps some critters out of them. So,
When does net metering kick in? Is it when you produce the power that you used, or does it include your base charge of $24.50?
That's a great question, and we'll talk about that in the economics. Yeah, the base charge is going to stay there, and that's sort of unique. Well, not unique, but the co-op world, typically our base charge is a little higher Makes sense. We're a densely populated co-op, and we have about 11 meters per mile of line. So that base charge is okay. There is truly like a facilities fee where it's the poles, the wires, everything like that, and you're still using it because you're interacting back and forth. So the lowest your bill you could be on the net metering is $24.50, and that's with anybody. That makes, yeah, great question. We talk about that in an example bill, but yes. All right, anything else? No, I'll let that slide. So let's jump right into small wind. So the key factor, velocity cubed. We got lots of that up here. Well, let's talk about that. Excuse my grammar there, but a 12 mile per hour moderate breeze can deliver over 3 times the energy of an 8 mile per hour gentle breeze. And most people, when you go out and stand in it, yeah, you're going to tell it's a little stronger, but, and that's the power of, going back to your high school calculus. When you cube something, it all comes from this power equation right there. I'm an economist, I like to talk with engineers. I had to include one equation, or just throw it in. But a couple things come into play. It's what drives how efficient a wind turbine is and what it produces. The area of the swept area of the blade. So when you see the utility scale ones that have the giant blades, I was talking to somebody earlier. It used to be a 747 spinning up there. If you wanted to think about it on side, now it's almost 2 of them, right? Swept area. The other thing that comes into play, and actually someone asked a question about this, is the density of the air. So yes, as you go up in elevation, production goes down. It still works at higher elevations, but all things being equal, it'd be better at lower elevation, and also temperature. It's going to work better when it's negative 30 out than when it's 115 in Phoenix. The air is denser. So that's what goes into a power equation. But why do I highlight this for wind? Siting really, really, really matters. And this is probably the bane of small wind. I'll tell you straight up, small wind is having a very, very hard time competing with solar. And we'll talk about why, some of the cost structures, some of the things that go with operational characteristics, but siting is a big one. If we want to talk solar, we'll show you a tool where you go on, you can draw it on this roof, and you get a pretty good guess within 2 to 3% what you're going to produce in the next year. Sometimes you'll have good solar years, sometimes bad, but on a whole, very predictable. We've got lots of long-term data on this. With wind, it really, really matters. And these are in here really just as illustrative. If you increase the tower height, the wind speed go up significantly. And actually the wind gets less turbulent, which is what's going on right there. If you see that house, or it could be whatever, that region of high turbulent flow, wind turbines do not like turbulence. In essence, you have to get above that. It's generally twice the height of the object, and in the turbulence, it's still impacting at 20 times the height of the object out. So if you think about siting, you're blessed with rolling, pleasant topography, different breaks of trees, homes, things like that. It begins to get difficult to site because you really want to get it up above it, and if you begin to get it up above it, then you have the aesthetic issues that sometimes come up with small wind. If you get it up above all this, you've got a really tall tower. So that's one of the big constraints when it comes to small wind. As far as like energy density, it's really concentrated solar energy is what it is. It works great on a large scale, but in a small scale, we've had some problems, and a lot of it's driven by siting. Somebody will go in like, well, I didn't want the taller tower because I didn't like that, so I lowered it down. How much different can the wind be from 30 feet to 45? Velocity cubed, turbulence. The biggest enemy of small wind turbines is wind. You get that turbulent flow, you don't get the production. And then also, and we'll talk about it here, first an installed cost. This is from the National Renewable Energy Lab. This is from 2016. I put an updated dot for what solar is. The costs have come down. But wind under 10 kW, which is about the size you'd be looking at, a wide range, but also relatively high costs relative to its competitor being solar. The idea being is solar got a lot better at manufacturing it. Wind is primarily steel and concrete. You're really at the mercy of the commodity markets when it comes to that. There hasn't been that significant drop. Solar panels are mostly made out of sand, right? So a little bit different. But so you have the initial installed cost of challenge, but really the big thing that comes with wind, and I can say this even from my time out in Wyoming, is operation and maintenance. So you see a wide band with wind, relatively narrow band and a lower band for solar. If you think about wind, I just talked about how important it was to put it up in a resource that's really strong, right? You want to get it in that strong wind. You're putting a moving object in the strongest wind possible. That can create challenges, right? Sort of like its own enemy can be a great resource. And you guys can have a really strong resource where it's actually even beyond the capabilities of the machine to produce. For instance, most machines will cut out at about 55 miles an hour to try and save themselves. They'll break and feather out. Some will try and spin free. But as you're putting it up to that extreme event, well, once again, you've got a moving part that is put in an extreme environment and also requires some operation and maintenance. Very reliable, amazingly robust machines. Don't want to downplay that. And there's some great manufacturers out there. We can talk about specifics there as well. Some great American-made turbines. Because it is a moving part, just think like an engine. Think like even something as robust as an electric motor. Occasionally, you have to do something to it. You've got to put some grease in it. You've got to take it down. So then you talk about, all right, do you climb the tower? Do you install a tower that's a tilt-down tower? It just makes maintenance a little bit more challenging. You put them in a spot with strong wind that's hard to get to because you had to. When they're 2.5, 3, 4 megawatts, so that's 4,000 kilowatts worth of energy, it's worth it to put it way up there and have guys that are absolutely crazy if you want a job, booming job, by the way. But those, the wind guys, that's amazing. They'll get up to it. There's a lot of movement in those things. You may not see it going down the road, but and that's worth it for them to climb up and do that difficult maintenance, things like that. But sometimes homeowners, you don't see that as much. See, that's my cue to like talk faster. But all right, so with that, and I know there's a lot of interest in wind, I will sort of transition to solar. But any other questions? I can talk about where wind makes the most sense, and that's when you need production at night. Which solar, I don't care how wonderful it is, it ain't going to do it for you. And that's primarily in an off-grid setting. So if you don't want to be net metered, you don't want to be connected to the electric grid, there's certainly a reason to do it independent. Sometimes it's just really expensive to get a line out there, right? It's just not worth it. Costs has come down with batteries, things like that. And you want production at night, well, wind can make sense there. Although as batteries get cheaper, it's starting to make less sense because then you store more sunshine. So. But specific questions on wind?
Yeah, so what are the restrictions in Larimer County for installing a generator? Example, what's the offset from a property line, the tallest tower, you can put it up. The largest machine, you put a 40 kW up. 40
kW, well, we'll talk about that. I'd have to defer. That would be something to check with the county. There are generally setback restrictions that you can't put this right on your neighbors on the property line. They do make a little bit of noise. Most people don't feel it obtrusive, but there is noise there. And like a 40 kW machine, that'd be a big wind turbine. But this resource,
impact studies.
I don't know. I can't speak for the county. I know it would go into like what we would have to do for a full-blown utility scale project. There probably would be more siting restrictions. 40 kW, once again, that's larger than any home would ever need. That would produce, probably 4 times what a usual home would consume. And we'd actually have some net metering challenges to get above that as well. But as far as the permitting, I'm not sure, what type of...
Some for up here.
Yeah, and then, once again, in the rural area, sometimes, and also homeowners association covenants, there's some protections on solar saying that in most cases you're able to do it. I don't know what you guys have as well. So that's sort of the first line, but after that I'd have to defer. We can follow up. I'll make sure you get my contact information. I don't want to speak out of turn. I know I've looked at them in the past, but we serve 3 counties. I don't want to quote you the wrong ones. So certainly is a concern. The siting can be, like I said, it is more obtrusive than like solar or other options. Certainly more obtrusive than changing your light bulbs. We'll give it that. So and I do have my machine. It's particularly useful for you.
We might do that.
No problem. This is that fun intermission. But I actually can jump into solar and what we talk about in solar. And one of the biggest things we can talk about is it's an exciting time in solar. And actually, if I were to draw you a graph, when I started, these conversations up in Wyoming, say 2004, if you are looking for solar, first of all, when I'm talking about solar, we're talking about photovoltaics. You see it's PV, and you're turning light into electricity. There's also solar that creates thermal energy. It's fallen out of favor a little bit, but in this case, we're talking about solar to electricity, so photovoltaics. But anyways, when I would have started, it would have been $7 a watt for a solar panel installed, maybe 8, maybe 9 in some cases. Now, when we see the residential price, and at the beginning of Q1 2019, it was $298 a watt installed. And the panels themselves have gone from maybe $450 a watt per panel all the way. The panels themselves are actually not the biggest cost anymore. It's all the soft costs that go with it, the permitting, the marketing, the wiring, everything that goes like that. We can talk why the US is higher than the rest of the world in that category, but the panels themselves are about 35 cents a watt. So it used to be when those were $4 a watt, and you had, we'll call it a 300 watt panel out there. Now, by the way, they sort of pack more energy into the same size panel, so they've gotten cheaper and, if you will, more energy dense over time. You know, you'd use like those bolts that made it so it was difficult to steal. I mean, this thing was $1,200 a panel. You put it out there for like a stock watering system where you pump water, and you'd be like nervous that somebody would go out there and, you know, lift that thing off. Now, you know, it's a bulk commodity, right? That panel, significantly less expensive at 35 cents a watt. And once again, are you going to go out and buy them 35 cents a watt? Probably not. When Poudre Valley goes out and buys 10,000 of them, we get it at that price. But shows sort of the commodity. So that's first why we're going to have this conversation. Go ahead.
I just wondered if you know whether the tariffs, because I've heard, have they affected the price of panels? 'Cause
Yeah.
Most of the panels come from China.
Yeah, a lot of them do come from China. A lot of our projects, Poudre Valley you talked to, had American-made panels. One of them has them from Malaysia. So yes, the tariffs had an impact. Matter of fact, we were building some projects right at that time, and the tariff had a real expense. And unfortunately, you as the members, it means that that project wasn't quite as profitable for you and the members as it could have been. So it did raise the cost, but markets are nimble, and China actually changed a policy for their domestic market that freed up a lot of panels where their manufacturers are just trying to dump them anyways. So it's increased it a little bit, but not as much as we would have anticipated. And once again, they shifted some of the production to other countries. A little bit of it came back to the US, and also just figured out how to work within the market. So it probably arrested that, you know, steady decline in pricing, but it hasn't been the death knell to the industry that some worry that it may be. So, great question. And folks are familiar, so was applied about 2 years ago was when the conversation started, and it really came into fruition. I know this all too well because we were building that project at the Larimer County landfill right in that summer. And it made our panel prices go up. So that's why we're having the conversation now, and why we're having it more regularly. Because it has gotten less expensive, the systems have got more reliable, they've gotten better and cheaper. That's a great way to move for the market, right? So how does a solar array work? You know, this is fun when you give talks to kids that get you up, and some of you would be photons, and you know, you'd have a solar panel in the middle, and some of you'd be electrons. Really, it's photons exciting electrons. No moving parts. The joy of the silicone panel, we've got, well, a semiconductor there. We won't go into too much, but in essence, photons excite electrons, you get direct current. All the electrons are flowing in one way. That's how the solar panel works. No moving parts. Generally a warranty of like 25 years, and it'll be like, well, it's sitting on the sun, it's going to degrade a little bit, but at the end of 25 years, it should be somewhere in that 83 to 87% of its rated capacity for production. So when we talk about the reliability component, no moving parts, and you just leave it sit there. That's why we see mostly solar on the installations on a private level, at the household level. Go ahead, ma'am.
Are they damaged by hail?
They can be, but they're pretty robust. If the solar panels got busted by hail, everything else has got busted. You've got windows out, you've got roofs gone, things like that, and I hope you had your car in the garage type thing. And they actually get tested. This gave me the national standard for it, but yes. And they shoot a 50 caliber ball at it at 55 miles an hour. It's sitting at a 45-degree angle, so it does deflect some of the energy. It's got to be able to stand that. So hail can be a problem, but like I said, if it's a problem for the panel, it's been a problem for other things. And sort of an example anecdotally is one of the first applications where we saw widespread solar adoption, once again, was in livestock watering systems, remote. Got rid of the wind charger, generator, trucking water, put them out in a hostile environment, and Wyoming did a project where they installed, 80 of the systems with state funding. 2 failed. One was shot by a 30-06, and they didn't do very well. That was a gas, a large caliber rifle. As I joked, it wasn't a 22, and the other one had a steer bust down the fence and split it in half. So, and 5 years, those were the 2 failure points of the pads. So.
Was that heating the water, or was that?
It's just pumping it. So if you want to think, you've got a stock well, I won't go too much in the ag, but it's a perfect application. When you got sun, it pumps water. You got a big tank. You don't need batteries. You don't need anything. It's just, the sun, turn a pump and put it onto the surface. Really, if you look around the landscape, you'll start the iconic Western water pumping windmill. They're still out there, but a lot of them, you look at the base and they've got a solar panel there. Just if anybody's in the ag background has ever had the privilege of climbing up to the top of one of those to try and pull it, I only got to do it once. You don't, let's keep that on the ground, thanks, right? Some 70-year-old wood tower that, wobbles in the wind, and guess what you get to do. But anyway, so solar, photons, electron, no moving parts. If you want to look at it, you have PV panels, and it goes to this magic thing called an inverter. That's where it takes that direct current to the alternating current, and that's where then it goes out and serves your electric load or flows out into the grid. Pretty straightforward process.
So would solar panels make a good? One of your charts showed how high our cost was to heat water.
Yeah.
Would that make a good application for solar to just have it connected to your hot water heater?
There's a couple of approaches. One is solar thermal, and I didn't prepare any slides on that, but if you want to talk about efficiency, the first thing we need to own up with a PV panel, we always talk about cost, but there is also efficiency. They're about, we'll go 17% efficient, thereabout, of converting energy into electricity. If you're doing thermal conversion, you're up in the 90%, at least above 80. So, a smaller, fewer panels can generate more heat. The challenge with solar thermal, and then we'll jump to another way to heat it, is you've always got the heat. It's not like this is flowing out onto the grid and you're dissipating energy. The biggest challenge with solar thermal, it's almost like wind. The biggest challenge with solar thermal is the sun. They heat, they blow themselves up because you didn't have an escape valve and you all of a sudden boil off your fluid, or the drain back didn't work well and you freeze it and the pipes blow off. So if you pay attention to them, people love them and they work great, but it can be an option. We'll certainly talk about that after. You'll hear a lot of solar installers argue, especially if you were going to put solar on your roof anyways, just upsize it a little bit and put in a really efficient electric water heater, probably a heat pump water heater. Heat pumps are sort of amazing. The refrigeration cycle, I alluded to them earlier. The magic of the refrigeration cycle, 1 unit of energy goes in and you get, depending on the temperature, say 2 units of usable energy out of it. It's because it's moving heat into your water. Pulls it out of the structure typically, but you'd be surprised that really doesn't have a detriment on the overall heating cost. And some would argue that that's an efficient way to do it. Go ahead and put a few more panels in and use it and put in an efficient water heater.
So with the inverter converting it from direct current to alternating current, you can use all your same appliances?
Yep. Now you certainly can have a DC system if anybody's had, although a lot of them have inverters anyways, but an RV system. And we can talk about batteries work in the DC realm too, and we'll talk about batteries, but they're, everything's the same. Yeah, for your case, you can't even tell. I mean, it's grid, actually the inverter is grid following, so it actually has the same sine wave that you're getting off our system. So, in the interest of time, I'll keep moving on. Great questions. I want to honor every time. Certainly, solar, PV, and wind incentives still matter. So you get net metering, which you talked about, but the other thing you get is residential renewable energy tax credit. 30% right now, and you can see how it steps down and then goes away in 2022. So if you spent $20,000 on a solar array, you get to take $6,000 off your taxes, not tax deduction, tax credit. One, you got to make sure you have a tax appetite to use it. Not going to give financial advice, but most folks, that's a big deal. So if you're installing it at $3 a watt, and maybe you can do better than that, by the way. That's why it's important to shop around. We'll talk about that. But you're out of pocket, if you will, after you get the tax credit, it's $210. So here's Meet BESS, the battery energy storage system. And when we talk about resiliency, if you have a solar array and you don't have a battery, if the power goes out, you don't have electricity. There's a couple of reasons for that. One, solar is variable production. So we talk about how we like that nice, neat level of voltage in hertz. That's what our appliances are meant to work on. your solar array on its own may not be able to support that. Say you've got some generation and electric resistance load kicks on, well, guess what? You're out of luck there. It'll, you won't be able to support the system. You have appliance damage. The other thing is the inverter is actually grid following, meaning it needs the grid to set the sine wave that is electricity, that's 60 hertz. So without a battery, if the power goes out, your solar is going to go out. That's one, a safety parameter, right? We don't want it backfeeding. If you think power is coming from the substation, it's coming from some other way. You can certainly isolate yourself. You run it in conjunction with the generator, but if you want your solar on when the power's off, you need a battery. So, question with that, sometimes people just assume you've got solar, you've got electricity, even when the lights are off.
I think this issue that you're talking about here may be a little bit more interesting to those of us up here, because a lot of people feel like they have more power outages. Up here.
Oh, you certainly do.
And so you see quite a few people, I don't know about Glacier, but some of the other areas up here, quite a few people are installing auxiliary generators.
Yep.
And whenever I see that, I'm like, why don't you buy a Tesla Powerwall or go into storing in your house? That there's advantages to going these other options. So
There is. And the basic anatomy of it, by the way, see a similar setup. The battery can either be coupled through its own inverter on the DC side, and then it's like an automatic transfer switch. And by the way, we have one at our office. Anybody who wants to wander in, it's a Sonin system, residential scale, but we can simulate an outage and you can see what it does. The exciting thing about batteries, it sort of follow that cost drop of solar. Are they cheap now? No, but they're a heck of a lot cheaper than we thought they'd be. And all of a sudden we are beginning to see them on our system. And how it would work, and by the way, if it's installed in conjunction with solar, you can also take the tax credit on it with some nuances, but that can help as well. And it does give you that resiliency. Now, is it like a generator where it can run flat out for 3 days if it had to? No, but it does allow you to, I can control and make sure I keep on my critical loads. I can either go down and flip my breakers, or it can do it automatically, things like that. You can just support critical loads. But it can be coupled into a system and provide that level of resiliency. And the other thing is, as your co-op, we're also working, remember how I said we had those peaks that set 40% of our bill? We do have an initiative to figure out if we can work with folks that have batteries and say, hey, if you let us access that battery and send us some juice at the specific time, you can monetize part of your investment or battery because it's helping us reduce our costs. Sort of makes sense there? So when to bring BESS home, if you want to look at it like that, you return to those whys. Is it going to save you money right now? Probably not. We're going to work on that, but is it like, this is a surefire investment for me? Probably not. Is there a technical fascination for it? Oh, huge. Like the bulk of our system's gone in, people are like, these are just great. You can get amazing power quality out of it if you've got really fine electronics. You like the other components of it, and you just you can pull it up on your phone, right? I mean, I could discharge our battery at the office right now if I had cell service, I guess. But most places. But anyways, technical fascination really drives batteries. Almost like the early days of solar. Same thing that initially drove EVs, and now it's sort of going mainstream. Independence and resiliency. That's where you get the big component. Does it fit into it? Yeah. How much are you going to pay for it? It's a $10,000 to $12,000 premium on a solar array for a smaller battery system. Maybe you can get a little less with the tax credit, but it's a premium, right? But is that premium worth in the context of resiliency? Maybe. And in your cases, maybe it's more likely that it is. Environmental concerns. There are some environmental concerns with the production of the battery, but a battery can also play like, I want to maximize my consumption of renewable energy. I really don't like those coal plants you guys have. You could store your solar energy and you get that electron, and you could actually say, I am indeed using all solar. There's probably other better ways to get at that, but we certainly see that as well. So the big one that it's going to hit on is the resiliency, and we could talk all evening on how it fits into a system where the battery manufacturers that are out there, certainly, here's a few of them. So that's those are Sonin systems. You have Tesla. That's it gives you an idea of the size. That's right there. It's a Sonin system. We have this one right here, and that's about a 14 kilowatt hour system. So it can store 14 kilowatt hours and release them at the rate of about 5 kW. So most people couldn't run everything in their house at 14 kilowatt hours. You can see why efficiency matters then, like an example with these lights, right? One of these is 150 watts, so 0.15 kilowatt hours consumed in an hour. If you made it more efficient, it would use less. But other ones, there's a Tesla Powerwall, Pika Energy has some stuff, and Iron Edison's actually a Colorado company. So there's a lot of good manufacturers out there.
So for instance, if you put one of those batteries in, like you got at the office, and you went and you turned your hot water heater off, and you only used your refrigerator, your freezer, and a few lights, what would that give you?
I don't mean to be obtuse, but is it winter or is it summer, right? If you got a couple to solar, as far as it getting some back.
Typically, it's going to be winter, that's when we usually lose.
Yeah. It all depends upon your efficiency, but if you look at a house really throttled down, likely uses about at least 1 to 2 kilowatt hours, or kW, so over the course of an hour, 1 to 2. So if you really throttle it down, you can get 8 hours or so out of that. It can also work in conjunction with a generator. You can fire up the generator and charge up the battery. Some have like interfaces for that. So if you've already got a generator, a portable generator, it can make it so the thing doesn't have to run nonstop. Or you can also put in more batteries and end up having more solar. So I was modeling that back of the envelope calculation on about a 10 kilowatt hour system.
I just have a quick question.
Sure.
I already have the solar.
Okay?
So getting the batteries attached, I'm assuming you're not going to get that credit because it's not attached. I got
Yeah,
credit for
I'm not your
solar.
tax advisor, but yes, that's my
Yeah.
understanding. So.
But then, cost-wise, I mean, obviously, doing it independently, you said the average is about 10 grand.
And by the way, that's very ballpark average. We can go on. Tesla is actually somewhat transparent with their pricing, but then they give you this, fluffy installation number, and can you get them to come out there and do it?
Right.
So the challenge is when you were putting it in, and say in conjunction with solar, you've got the master electrician there. You've got the installers there. They just put something else in the truck. When you hook it up, it's actually like, it's stamped by Underwriter Labs as like installing a water heater, an electric water heater. It's an appliance. It's like in the oven, the range. And it's just one more thing for them to plug in while they're there. So it's, that trip time really matters when it comes to it. But with that being said, technically, there's no problem integrating it into a solar array, especially with an AC coupled battery. If you want to think about it, you just put in a redundant inverter and sit right here, if you will. And it would interact back and forth. Matter of fact, at the office, that's how ours is. It's got its own inverter. It stores in DC, so it's converting back and forth.
Did the batteries last long?
Now, we don't have the actual numbers to say this, like, hey, they've been around for 15 years, but folks are pretty confident in the chemistries. Most of like the lithium ion, which really dominate the market. There's some other ones out there. Some people still use lead acid, but when we talk about lithium ion, most of them are going to come with a 7 to 10 year, 10,000 cycle warranty. They'll degrade a little bit. We are getting a pretty good feel for them out of the electric vehicle industry. Like if you're looking at a Tesla, it's the exact same cell that's in a Model 3 or whatever. And they work those things hard, they slam them, if you've ever driven an electric vehicle, like them or not, it is torque, right? And torque is fun in a vehicle. So, people hammer them and, regenerative braking. So, yeah, we think they last, but like anything, you're introducing a new element into your home and it could, there could be issues with that.
So are they comparable, these different battery systems?
As far as the manufacturers, each one will tell you they're the best, but really it's getting access to the installer. That's a primary failure point. Heck, it's a primary failure point on any of these distributed generation systems. Is it put in right? I'd be fairly safe to say that, Sonnen has like a slightly different chemistry that may make it a little bit safer and last a little bit longer than Tesla, but it's also 50% more. Pika came out of the off-grid, so they're more focused on that. So they all have their niche, but once you get into it, you're really looking at how much energy can you store and what's the degradation, and also your guess at how much you're going to cycle it. If you just got it around for reliability, if you have to cycle that thing 10,000 times, you should have called our office lots if your power is going off that much. So if you just have reliability, hopefully that thing doesn't cycle very often, so you're mitigating that impact of having it cycle a lot.
Does the ROI take into account the disposal fee of the batteries after they're at
That's a wild card because there's valuable elements in it. So when it comes back to being recycled, there's actually a play like, for instance, Nissan with the Nissan Leaf. They'll take them out of vehicles when they've sort of degraded over time, but still just fine to have it sitting on your wall. You just don't want to lug it around in a car. You need more energy density. And they actually have a program where they'll put them into homes now, right? Mercedes will do the same thing. I can't give you a real good answer on the recycling app because most of them are new enough that they're still in service, and we'll see. There's always a risk that the chemistry changes, and it's sort of like, remember TVs, the glass front TVs, where you used to get paid for them. Now, then you had to pay to get rid of them, and now I don't even know what you do with them, right? So.
You're doing solar, you got a battery.
Yep.
But like you said, you're not using it because you don't know what it is. But you are feeding it back to the grid. Does that go through the battery and then get back to the grid? So you are using your battery?
Generally, the battery will top itself off with a charge controller, and then it'll send it back to the grid. So it isn't like you're discharging your battery constantly. You can set it up to do that. Like say you wanted really smooth power quality or something, you can ask it to fluctuate a little bit like that. But generally, it's wired where there's a charge controller. It'll say I want it to charge this time or get it to whatever level of charge, state of charge, but it's generally when it's full, it's just a direct feed into the grid. Great question.
What's the?
Oh, go ahead. And by the way, before I want to be respectful of folks' time, you guys, as I hope, have a lot of great questions. Not going to offend me if you need to wander off or if you want me to, get to the end here. But these are great questions. I want to make sure I'm just honoring your time.
I was just wondering if you've got an electrician to put the solar panels on. What's the time element? Because they're obviously going to have you guys out there to hook it to the grid, right?
That's a great segue. And the tail end, yes, you go through that interconnection process where we give you a form, pretty straightforward. Most of the installers know how to do it. We have disconnects, a placarding, things like that. And after it's done and it passes an electrical inspection, we get notified that. We come out and set that net meter. Typically, we'll try and get that done in, there's only one guy in the office that does it, but 2 weeks or so. Generally, it's less than that. But interconnection, as long as it's done right with a reputable installer, typically is a non-issue.
Yeah, they have no issue.
Yeah, it's pretty straightforward, especially if you got a good installer.
I have a question
Sure.
about the solar collection panels down on Riverside.
Sure, that's City of Fort Collins, yep.
Yeah, I'm just curious. My understanding is that one could buy power through the city as it's stored there.
So that's a community solar that I alluded to at the beginning. Poudre Valley, we've got 3 projects. One that is open next to the landfill. So it doesn't store energy. It's going on the grid. Remember, it's consumed the moment it's produced. We don't really care where it's going on our grid within reason. System engineers would cringe at that statement. But you get to subscribe to the output of a certain number of panels. Say, okay, I need 20 panels. They produce about 465 kilowatt hours per panel per year. Boom. We take a portion of that project and we give you credit on the bill. It goes through net metering, just like that. So
is it kind of like renting a panel?
Our early ones, you actually purchase the panel. As we got into it, there's some securities issues that go with that. A third party had done that. And when the co-op we did it, in essence, it's a subscription. So it is sort of like renting it, if you will. There's only so many panels out there, and say there's 6,102 actually, and say you get 10 of them, right? You get 10 6,102 seconds out of that. So, but it's a subscription. The price can't go up; it can only go down. We want to make sure it's good for you. So. Now I've got some materials up on that. I didn't want to hijack anything and not talk about private solar. Real quickly, and you can see these in the slides, I expected an engaged audience, and I expect that you may want to go home and, I'm a little curious on this. So I wanted to give you 2 tools that aren't the utility, right? It isn't the co-op, and it isn't an installer that's trying to sell you something. And the 2 tools are the National Renewable Energy Lab PV Watts calculator. And this allows you to, in essence, size an array. And I'll click through a couple quick slides. And then the Colorado State Extension. You guys may have had Extension present out here at some point. But they also have a solar calculator that's great on the economics. Gives you a nice true look. Just an example, I drew a solar array on the fire station. And you literally can go on Google Maps and draw the array on there, right? It tells you that worked out to about a 24 kW DC system, and it gives you an estimate on what the production is going to be. There's a range in there, but very simple to use. It's free. Like I said, it's provided by the National Renewable Energy Lab, industry standard, been around for a long time. But you can play, you can figure out what I could produce. They used to have a wind one, but once again, that siting was so challenging that they actually took it down. CSU solar calculator does sort of the same thing, but a little less granular. But it does get in and does an excellent job giving you an honest take on cost benefit. And at least what it does is then when you go and talk to an installer, their numbers may be different, but you get to ask why. Right? Why is that lower? Why is that higher? Why is your payback half the time that CSU says? Why is it twice as long? And very easy to use as well. Here I just ran one, for a typical home that uses 12,000 kilowatt hours. You can see the install cost, tax credit, savings, and right here it's showing about a 19-year payback at Poudre Valley rates. It gives you cash flow, and the only thing I like about it, it also gives you assumptions. Once again, free, and if you want to, work with extension after that, they'll follow up as well. So the next steps, if you're looking at private wind and solar, first compare your options, and remember your why. I really hammered on that for a reason. What are you trying to get at? Maybe you replace all your light bulbs, or maybe you put in a heat pump water heater. Really addressing your why first, and then you can get to it. It's not saying you just can't put solar up, but maybe you didn't get after what you were trying to do the best way possible, be it resiliency or whatever. Then assess your energy use. We're happy to walk through your energy use. If you really got something crazy that we see on there, we'll come out and do a free energy assessment too. So we'll walk through your house. If we see something really like we can't explain it, looking at the daily intervals and talking to you, so we'll do a free walkthrough. But talked about the PVREA app. There's the website there. And then if you decide that private wind or solar, and I sort of badmouth wind, but hey, if you want to go wind, we can go that direction. It's really, really important to get multiple bids. It's amazing the price discrepancies. Primarily because there is such that high acquisition cost, so soft costs. Some people really bake them in there, right? Door to door, knock knock. Folks can run it more expensive than the local installers. And as for qualifications, a great one's NABCEP, North American Board Certified Energy Practitioner. And then the other thing, we talked about the interconnection process. Always good to contact us early. And here's what Poudre Valley is our role in this. We're going to make sure it's safe first and foremost. You want that, we want that, everybody wants that one. But that's sort of that's our foundation. Then we address any system impacts. They can be good or bad. We can talk about those voltage regulators. Maybe it actually helps us support voltage in an area. It's good. Or maybe there's some things that we have to look at to change. Maybe you have a small transformer. And then we provide that accurate net billing. So your first step, you can call us. If you're just looking to get set up, it's sometimes easier to call on the front. We've got a great website that walks through the process. Or I'm always happy to chat about this. You can call me directly. That's my direct line, my direct email, and we're happy to get you steered in the right direction. I apologize for going over a bit here, but once again, great questions, and I'm not going anywhere. I'm happy to address any questions from how the co-op interacts with it, to efficiency, to wind, to solar, really fair game. So.